Hello everyone. Today I will be solving an easy problem from Codeforces. It was given by a friend last night. So the title of the problem is preferred value. There are time limit, memory limit, input output. So the problem states a unique community of iguanas has made their home. These iguanas are known for their discerning tastes when it comes to choosing a place to live. They have found an area with exactly two valleys where the terrain forms a distinct W shape. So it forms distinct W shape, which is this W shape. This terrain can be viewed as a series of n height values. So they are just these points are heights of this terrain, yeah, height of these values from the ground. So these values begin with a local maxima, strictly decrease to local minimum, strictly increase to local maximum, strictly decrease to a local minimum again, and then strictly increase to a final local maximum. So this is LMA, local maxima. This is also a local maxima. This is a local minima. This is also the final local maxima, though there are three local maxima and two local minima here. One. These charming iguanas want to find the perfect spot. Each of the values has a bottommost point and they will select between one of these points. In particular, they would like to pick the highest bottom as it has the best views and the most comfortable basking. Then highest bottom. The highest bottom has to be in these two local minimum. Say the x is a local minima and y is local minima. So if y is greater than x, then we have to choose y as the highest value bottom. So given a terrain with exactly two values represented as a set of integers, your task is to find the height of the highest bottom of a valley. So input is the first line contains an integer n. So it is the n has to be between 5 to 1000. Remember that if we enter 4 or give 3, the code will not run because it will not shape W has to be shaped in 5 points. 1, 2, 3, 4, 5. So representing the number of the terrain, the second line contains n integers representing the heights of the terrain in specific points. So there W has 5. We can also 7, 8, 9. And so go on. It has to be 1 to 10 to the power 5, representing the heights of the terrain at specific points. These specific points are the heights of the valleys. They are guaranteed to form W shape as described in the problem statement. So if we given nine heights, so we have to form W from the 5 heights. So it has to be W. The statement here described that output will be a single integer, the height of the highest bottom of the value among two valleys. So we have to input first. So we have now write in the code n, which has to be integer. So we will be taking it input integer, and then these are the white spaces will be the sets of the value. So we will make a list of heights to store this value. So list, and we will use map function to input the integers, and also use the split function. So we have now taken input in representing the height values, and hi represents the sets of integer of heights. Now what does it say? So 4213645, we will be taking this in a list 0 2 3 4 5 6. So these are the index of this list. 421342645. So suppose we will be making W shape. We have to make W shape. So we will be starting our local maxima, let's say 4, then will be 2, and then 1. So 4 and 1 both are local maximum, but 2 has to be local minima. But here we can see 2 is less than 4 but greater than 1. Does it satisfy our local minima and local maxima concept? No, it is wrong. So we can't form any W with this. Next, we will go to the index 1, index 2, because we have verified index 1. So index 2 will be 2 1 3. So now we can see that if we take local minima 1 and local maxima 2 and 3, 1 is less than 2 and also less than 3. So it is satisfying our valley. So we can make a valley in this shape. So this preceding and succeeding and as well as the valley bottom is right. So where did we get this value? At index 2. So we will be in the storing index 2 and value 1. So our first valley bottom is 1. So index is 2. So now we will have to move and skip the next index because we can't use the preceding and succeeding values of this we can't use the same succeeding and preceding value of the first valley bottom. They will clash and will not form W. So we have found it in index 2. So we'll start looking from index 4 because we have to compare between 3 values, a succeeding, preceding, and the valley bottom. So we take succeeding value as 3 and preceding value as 3 and succeeding value as 4 and valley bottom as 6. So it is not happening because 3 and 4 is less than 6. 6 has to be local minima, not maxima. So it will form in this, not this, this will not form a valley which we are looking for. So we will go to the next index 5. 5 stores 4. The preceding value is 6 and the succeeding value is 5. So we have 4. Look, 6 and 5 both are greater than 4. So we have found our second valley bottom. which is 4, and index is 5. So between 4 and 1, which is greater? Which is the highest? So obviously 4. So this is our result. So we now see the output. Yes, the output is 4. This means our theory is right. So we have now to implement it in the code. So just we have to traverse through the list. So we will use a for loop for that. We will starting our first index from 1 to n minus 1, which will be not included. It will, let's say n is 7, so n minus 1 will be 6. So the loop will run through to 1 to 4. It will not include 5 in the range. So if 5 is less than the, what is the previous index of I? Obviously it is I minus 1. And the next is I plus 1. Then we will be storing, sorry, first value equal to 0, second value equal to 0. So we will use the first value equal to 5 and break, and now have to find the second. We will use I plus 2 because I is the index of the first value bottom, and we have to skip the next value. So we have to add 2 to do that, and we will use n minus 1, or there will be index error, just like the previous one. We have to write this. Okay, right. So now we have two values, first and second. We now have to just find the maximum of those two. We will use built-in max function to do that. First value and the second value, and print result. So we now run our code. Oh, why we have done wrong? Press 10, control N. Now enter 7, then 4, 5, 4, sorry, 4, let's see. Oh, did not copy. Oh, the output is 4, which matches our output. So the code is done. We just now have to submit it in the judge so that we can see. But I am not going to do that. You can, if you register here, you will see a submit button. So the judge can run your code. If your code is accepted, that it means a successful solution. If it not, so try again. I have already submitted the code beforehand, so I am not submitting it again. Hope you have understand my this little problem. So if you like this problem, please like and subscribe and comment any problems if you face. So this is for today.